Study about the area of a parallelogram. First, we have to know what a parallelogram is. Consider a quadrilateral A, B, C, D. Suppose this is how the quadrilateral looks like. Then you have to remember that write A, B, C comes here and D comes here. Now the name shows you in what order the vertices have to come. So A is followed by B and B is followed by C. C comes here and not here. And the name just doesn't show us the order of the vertices. It also shows us the names of the sides and that of the diagonals. How do you find the names from just by the name of a quadrilateral? Look at the adjacent vertices. Adjacent means nearby. Look at the nearby vertices, that will show you the sides. So what will be the sides? AB, BC, CD and DA will be the sides. And what will be the diagonals? The alternate vertices. What is alternate? You take one and then you skip one. So take A, then skip B, here C. So AC will be a diagonal and BD will be the other diagonal. Now what will you happen if you write like this? If you write AB and CD, that means what will be its sides? This quadrilateral's name will be ABDC. It is completely another quadrilateral. Its sides will be AB, BD, DC and CA. So you see the difference here. Here AC is a diagonal, but here AC is a side. So be careful of that. When the quadrilateral's name is given as ABCD, you can write A wherever you want. It does not matter. You can even start A from here. What matters is that you keep the order. A is followed by B, followed by C, followed by D. Now take a special case of a quadrilateral ABCD. A quadrilateral which satisfies three conditions. We will see what the three conditions are. First, let us name it A, B, C, D. It satisfies three conditions. First condition is that opposite sides are equal. So what are the opposite sides? AB, DC. So AB is equal to DC and these are also two opposite sides, AD and BC. So its opposite sides are equal. That is the first condition. Second condition is that the opposite sides are not only equal, they are also parallel. That means AB equal and parallel to DC and AD parallel and equal to BC. Now what do you mean by parallel? Parallel means two lines like this are said to be parallel, like 11. Two lines like this will be parallel. It means that however much you stretch them, they will never meet. They will always remain like this. But what happens if one of the lines is like this? It may not meet here, but eventually if you stretch it enough, at some place that they will, down the road, they will meet somewhere. But if they are parallel, they will never meet however much you stretch them. So these are the first two conditions. The third condition is that opposite sides are equal. So AB, what is A's opposite angles? Opposite angles are equal. What do you mean by an opposite angle? These two angles A and C are opposite if they do not share a common side. Now what about A and B? Look at this. They have the common side AB. This is angle A and this is angle B. So what are these two angles? They are adjacent. They are nearby. But then what about A and C? You see they have nothing in common. The arms of A are AD and BC. And the arms of C are BC and DC. So they have nothing in common. These are the opposite angles. So angle A is equal to angle C. Then angle D is equal to angle B. So these are the three conditions that this quadrilateral satisfies. What are all they? Opposite sides are equal and parallel, and opposite angles are equal. If it satisfies these three conditions, it is called a parallelogram. Now, this parallelogram is like what you can say a father of rectangle and square, and also rhombus. What does it mean? Every square, every rectangle, every rhombus, they are all parallelograms. Now, why is that? I will tell you why. So, we saw what a parallelogram is. It is any quadrilateral which satisfies three conditions. What are the three conditions? Its opposite sides are equal. If this is 5 centimeter, then BC will also be 5 centimeter. If this is 7 centimeter, AD will also be 7 centimeters, and they will always be parallel, and the opposite angles will be equal. Angle A and angle C will be equal, and angle B and angle D will be equal. Now, every rectangle is a parallelogram. What do we mean by that? If you remember in our previous video about rectangles and squares, we considered an example. Remember that every fruit, if you consider fruit, every fruit is not an orange, but every orange is a fruit. What does that mean? Orange is just a kind of a fruit, right? So every orange will be a fruit, but every fruit need not be an orange. Why is that? To be an orange, some extra conditions has to be satisfied. It has to be orange in color, it has to be a citrus fruit, it has to have a peel, so on and so forth. So, orange, being an orange means more conditions. So, every orange is a fruit, but every fruit is not an orange. Just like that, parallelogram, if you consider parallelogram and rectangles, every rectangle is a parallelogram. Why? Because being rectangle means you have to satisfy more conditions. All these conditions will also be satisfied for a rectangle, plus etc. Extra, it has to satisfy one more condition. What is that? For any rectangle PQRS, for any parallelogram to be a rectangle, it has to, of course, it will satisfy all these conditions, plus it has to satisfy a fourth condition, which is all angles are 90 degrees. So parallelogram just has to satisfy these three conditions. That is enough. It will be a parallelogram. But if it has to be a rectangle, it has to satisfy one more conditions. All angles have to be 90. So can every parallelogram be a rectangle? The answer is no. What if for opposite sides, suppose angle A is equal to angle C is equal to 80 degrees, and what if angle B and angle D are equal to say 100 degrees? So it is a parallelogram, right? All these conditions are satisfied, and you have A and C is 80 and D and B is 100. So all the sides, all the angles of a parallelogram should together add up to 360 degrees. That's all you need. All of them do not have to be equal. Just opposite angles have to be equal, and all the four of them together should add up to 360 degrees. So look at this particular parallelogram. It can never be a rectangle. Why? Because if it is a rectangle, all of its angles should be 90 degrees. So every rectangle is a parallelogram, but every parallelogram is not a rectangle. Now consider a square. Square is a even more special case. So it is like you have fruits, then you have oranges, then a special kind of oranges, say clementine oranges. So it's a special kind of oranges. So what do you have from that? Every square will be a rectangle. Why? Because to be a square, you have to satisfy all of this plus extra one condition, which is that all sides also have to be equal. So all squares will be parallelograms, but all parallelograms will not be squares. Why? Because in a parallelogram, just the opposite sides have to be equal. If this is 5, this has to be 5. If this is 7, this side also has to be 7. But there is no condition that all of them have to be equal. So that is how it works. All the squares, all the rectangles are all parallelograms, but parallelograms need not be a rectangle. Parallelograms need not be a square. Now we come to the topic on hand, which is the area of a parallelogram. Now we come to the area of a parallelogram. Consider a parallelogram. Consider a parallelogram P, Q, R, S. Remember, they have to come in order. Then, if this length RS is suppose B and its corresponding height is H, then the area is B into H. Now, what does this H mean? You know what the B is, right? It is any side. So what is this thing height that we are talking about? It has to satisfy two conditions. For the height of, when we say the height of any side, what does it mean? It should be a line from an opposite vertex. Now what do you mean by an opposite vertex? If you consider SR, what are the two vertices which are connected to SR? S and R, of course. So anything which is not SR is its opposite vertex. So how many opposite vertex does it have? Two. P here, Q here. So it has two opposite vertices, P and Q. So any line which is either from P or Q. And what is the second condition it has to satisfy? It has to meet RS in a right angle. So suppose if this is a line, say PL, then PL should be perpendicular to RS. These two conditions have to be satisfied. Now what we have drawn is a line from P towards RS. What about Q? If you draw from Q, how will it look like? I will show you. Just one second. Let me clear this. We have drawn from P. Now we will draw from Q. It will be a height, but it will be the altitude, but it will lie outside the parallelogram. Why? Because if you draw a straight line from Q such that it meets RS, look at it, it falls outside the parallelogram. And what will its height be? Suppose this B, say, is 7 centimeter, and suppose H is 3 centimeter, then we already know the area, right? What will be the area? Area will be 3 centimeter into 7 centimeter, which is 21 centimeters. Now again we discussed this units in the previous class itself, right? If we do 2 into 4 centimeter, it will be 8 centimeter. But at the same time, if you multiply 2 centimeter into 4 centimeter, then that will be 8 centimeter square. That is why areas are always measured in square units. We already discussed that, but I just wanted to mention it, that the area, it has centimeter square. So what is the area of the parallelogram? It will be the side by its height, which is 21 centimeters. Now, what if we are measuring from Q? Then this will be same. The side will be the same. But what do you think its height will be? Will its height be 3? What if it's not 3? What if it is 4? Then how will it look like? If the height from Q to SR, instead of 3, suppose it is 4, then how will this SR look like? It will look like this. Or in other words, it will not be a parallelogram. It will look like this. And what does that mean? It cannot be a parallelogram. So there is no way that this can be anything other than 3. Right? So if you take any side and go to its opposite vertex and draw a line which meets it in a right angle, then that is called its height. And from any two vertices, if you draw to the same side, the height will also be same. Now comes another question. Can we draw it from only one side? The answer is no. From any side you can have a corresponding altitude. Now if you were to consider QR, how will its corresponding altitude look like? There you have again the same picture, but then I am drawing it over here. P, Q, R, S. Now suppose I do not know what SR is. So here suppose it was given as 7 centimeter, but here I don't know what it is. What I know is QR. Suppose QR is 10 centimeter. Then what is how does the corresponding altitude of QR look like? It should be a line from the opposite vertex. So if QR is a line, what are the opposite vertex? It has two opposite vertex, P and S. So a line from that, and what is the second condition it has to satisfy? It should meet, it is a straight line and it should meet it in a right angle. So if suppose this one is 4 centimeter, now again what will be the area? 10 centimeter into 4 centimeter, which is 40 centimeter square. So basically what the equation says is that a side and its corresponding altitude. It is like having a door and a key. If there are 4 doors, they will have different keys. So just like that, if you have two sides, two different sides, this side will have an altitude which looks like this, and this side will have an altitude which looks like this. Two different ones, but what should be equal? So suppose if this is 4 centimeter and this is 10 centimeter, let us suppose this is 5 centimeter. Now try to do this question. See here, you have a parallelogram and you have two altitudes. One from P towards QR, which is 4 centimeter, and its corresponding side. One corresponding side, one corresponding altitude. So what is area? Area will be 4 into 10, which is 40 centimeters. But then it is the same area, right? So it can also be expressed as, suppose if this length is L, area is also 5 centimeter into L centimeter, which is 5L centimeters. The area can be expressed in both the ways. So that means these both are equal. So 40 will be equal to 5L. That means L will be equal to 8. So this has to be 8. Why? Because 5 into 8 will give 40. 4 into 10 will also give 40. Now, if you want, I can tell you how we get the this formula. I don't think it is needed for a 7th grade because this is just an introduction to the parallelogram. You may not need it, but it's a very interesting proof. I just want to share it with you. So suppose we have a parallelogram, say A, B, C, D. What we are going to find is, how did we find out that area is B into H? So let us see. Suppose it's one side is B and its corresponding altitude is H. So what if we break it here? Then it will look like this. Right? It will look like this. And what will this separate part look like? This separate part will look like this, which is this part and this part. Now, what if you take this part here, move it here, then what will this look like? It will look like this. So you see what we have done here. We have taken a parallelogram and made it into a rectangle. And now what is the area of the rectangle? It is length into breadth, or in other words, B into H. It's like we got the area of a parallelogram from the area of a rectangle. Now let's go to triangle. The area of the triangle you can get from the area of a parallelogram. That is interesting, isn't it? Let us see how it works. Now consider a parallelogram A, B, CD. We know what the area of a parallelogram is. It is any side into its height. It is B into height. Now, what if you cut across this? Take the diagonal. What is the diagonal? It is AC. Now, what do you have? You have a triangle ACD. You have a triangle ACD. Now, if all of this is B into H, half of it would be half of B into H. That is the area of a triangle. Now, similarly, just like we did with the parallelogram, you have to understand that for every side there is a corresponding altitude. Now, what do I mean by that? Look at ABC. Now, if you take any side, for example, BC. Suppose BC is suppose B. Now, how will its corresponding altitude look like? It has only one opposite vertex. In parallelogram, there were two opposite vertices, but in triangle, every side has only one opposite vertex, and from that opposite vertex, a line which comes to BC and meets it in a right angle. So, what will be the area of ABC? It will be half of, if this is B and this is H, it will be half BH. Or in other words, if one side is say 10 and its corresponding length is say 7, then the area will be half of 7 into 10, which is 35. Now, not all altitudes will be inside. Some will also come outside. I will show you how that looks like. Consider such a triangle. Okay, again ABC. Here you have BC, and what is its opposite vertex? A. If you draw a straight line from A, what do you see? It lies outside the triangle. So what do? You have to extend CB towards this so that it meets here, say in some point E. Now, if again, but the formula is going to be same. If BC is again say 10 centimeter, and if this AE is say 5 centimeter, what will be the area? Half of 5 into 10, 50, which is 25. Now, what about a right angled triangle? Look at a right angled triangle. Again, let's stick with ABC. Right? Now, what do you have? If you have BC as a side, say 10 centimeter, how does the altitude look like? What is the altitude? It is a line from the opposite vertex such that it meets BC in a right angle. So, what do you have here? You don't need an altitude from outside. It is this side. AB itself is the side you are looking for. If AB is say 12, you understand how this becomes the altitude? So you will see that in a right angled triangle, both of the sides, leave the hypotenuse, both these sides are altitudes of one another. Either, see, if you take this side, then what is its opposite vertex? It is C. Then a straight line which joins AB in a right angle would be CB. Similarly, if you take BC, opposite vertex is A, it meets it in a right angle. So what happens? These two are altitudes of one another. So what will be its area? It will be half of 12 into 10, which is 12 into 5, and that would be 60. And always remember, it is the area is measured in square units. Now we come to the last section. We know how to find the area of a parallelogram. We know how to find the area of a triangle. Then what about irregular shapes? So how do we find the area of FECD? Now it is not anything that we have learnt. It is not a triangle. It is a four-sided figure, but it is not a parallelogram. It is not a rectangle. It's not anything we know. But what do we know? There are other figures that we know. Look at the places which are excluded. What are the two sections which are excluded? There is this section and there is this section. So what if we find the area of the complete figure and then subtract these two figures from it? Then that should give us the answer. Now what does the complete figure look like? It is a rectangle. And what will be the name of that rectangle? It will be A, B, C, D. And what will be its sides? Look here, this much is 8 and this much is 10 and this much is 8. Together they are 18. 18 here, 18 here. That shows you and also 10 here, 10 here. Here it is 10. Here it is 4 plus 6, 10. So opposite sides are equal. That means it is a rectangle. So then what is the area of this whole thing? It will be 18 into 10. Do not forget the unit, centimeter square, which is 180 centimeter square. The whole thing is 180 centimeter square. Now look at this one. This is a triangle. For triangle, what all do you need? You need one side and its corresponding altitude. But then rectangle, what did we learn first? Rectangle means all the sides are 90 degrees. Or in other words, if you consider this as a side, then EB will be its altitude, because this is a right angle. So what will be the area of EBC? It will be half of 8 into 10, that would be 80, and the answer would be 40. Again, do not forget the unit, centimeter square. Now what about this? This is a rectangle, so here also it is 90 degrees. So what is the area of AEF? That is equal to half of 4 into 10, which is 40. So the answer is 20 centimeter square. So if the total thing is 180 and this much is 20 and this much is 40, so together they will be 60. So a 180 minus 60 would give you 120 centimeters square. So this much area is 120 centimeters square. But it is an irregular figure. It is not anything you know. It is not a rectangle. It's not a parallelogram. But if you exclude the known figures, you will get this area. Let us just see one more example. Look at this triangle. It is clearly an isosceles triangle. Why? Because two sides are equal. AB and AC are both 7.5 centimeters. And now we have the third side and its corresponding altitude. So how will you find the area of ABC? You have three sides here, but this is an altitude drawn to BC from its opposite vertex. So the area will be half of the side into its altitude. That is, so the answer would be 27 centimeter square. Now what if we consider this altitude? That is, look at the side AB, its opposite vertex is C. Then from C, if we draw an altitude, how much do you think that would be? Again, you can use the formula for the area. What will be the area of ABC? You can find the area of ABC in not just one way. You can find it in three ways. You can take this side, corresponding altitude, this side, corresponding altitude, and the third side, a corresponding altitude. You will get three different equations, but the answer should always be the same, because the triangle can have only one area. So whichever side and the corresponding altitude you take, your answer should be same. So area of ABC is this side, corresponding altitude, or this side, its corresponding altitude, which is half into 7.5. Suppose it is equal to x. but then area is going to be same, right? Whichever way you take it, the area of the triangle is going to be same. So that is 27 is equal to 7.5 by 2 into x. That means x is equal to 27 into 2 by 7.5, and let me find out the answer. And that is equal to 7.2. Do not forget the unit. It will be centimeter. Each of the areas is centimeter square. The side will be centimeter. That's all for today. This is actually our second class on area. So we have covered rectangles, squares, parallelograms and triangles. And inshallah in the next class we will see the circumference and the area of a circle. So till we meet again, stay safe. Salam alaikum.